Kia ora and welcome to a new Scholarship Calculus series here on YouTube. I'm naming this one Insightful Integration. Not all the problems involve insight. Some of them are pretty brute force, but when given a thesaurus and a list of descriptive words starting with I, things like inept and inconsistent and other words starting with I didn't quite fit the bill. So, insightful integration. Hopefully, this series is as useful as previous series have been for your study with scholarship calculus. Let's get stuck straight into the first problem. This problem here has a sneaky trick to it, as some of the problems do in this series. Pretty standard scholarship problem where you're given an integral a bit different to your NCA ones, and you need to find some method of attack. We are going to look at problems in this series that involve trig substitutions and other skills, but this one here just requires a little bit of algebra. So I'll leave you with that hint. All the best for this problem, and solution, as always, on the flip side after the intro music.
Alrighty, as you're probably aware, integration is a lot more wide-ranging than differentiation. You need a lot more tools in your toolbox. When you see an integral, the first thing you should consider is the reverse chain rule or simple substitution. If a simple substitution doesn't work, then try something fancier. By fancy, I mean trig substitutions, and you're going to see those later in this series. However, usually, if it's a difficult one, there will be a hint. Therefore, this integral here with no hint, it's probably a straightforward substitution. So we could start with considering u is equal to x to the 6 minus x to the 9. And that makes the integral definitely simpler, because if we're integrating the cube root of the stuff underneath there, it becomes u. So that's a lot nicer. But the problem with this substitution is that the dx part, we also need to replace that dx. The differential doesn't get any nicer, because if we differentiate our substitution, du dx is 6x to the 5 minus 9x to the 8. We then need to rearrange that, replace the dx, we get du divided by 6x to the 5 minus 9x to the 8, and we've still got an integral that's got u's and 2 letters in it. It's still got x's in it. And look, we could then somehow rearrange the substitution, make x the subject of it. It looks, is it a disguised quadratic there? No. But if we somehow miraculously rearrange that, then we would then need to substitute it into there and into there, and we would end up with a horrendous integral, one that was worse than what we started with. So simple substitution is not going to help us with this particular integral, which means we need to consider something a little bit different. The idea is when you make a substitution, you want to simplify the problem. And you want to pick your substitution such that the derivative of it appears in the problem as well, because we need to replace the differential. So if I play around a little bit with this integral to begin with and factor out x to the 6 out of the thing underneath the square root. So I've got integral cube root. If I factor x to the 6 out, then I've got 1 minus x cubed. And then the x to the 6 can be pulled out of the cube root, because the cube root of two things multiplied is just the cube root of one times the cube root of the other. So we end up with, it's a terrible integral symbol, cube root of x to the 6 multiplied by the cube root of 1 minus x cubed. Algebraically simplifying the problem often helps. Cube root of x to the 6 is just x squared. And now we can make the simple substitution. What I was saying earlier is that if we make this substitution, the derivative of it appears in the problem as well, or almost does. So if I say here, let u equal 1 minus x cubed, then du is equal to minus 3x squared dx, and we've got the x squared part appearing there, and the x squared dx can be replaced by du divided by minus 3. So I'm integrating the cube root of u times du over minus 3. And dividing by minus 3 is a lot nicer than what we were dividing by earlier. So just pull the factor of minus 3 in the denominator out as minus 1/3, and the cube root of u is u to the third. And now we're integrating something a lot easier. U to the third integrates to u to the 4/3 divided by 4/3. We're also got the minus 1/3 in the front and a plus c. And then we can simplify that. Minus 1/3 divided by 4/3 is minus 1/4. And u to the 4/3, if we wanted to, could be written as u to the 4 cube rooted. You don't have to do it that way. And then the last thing we need to do is replace the u, because we put it into the problem, with the substitution, which was 1 minus x cubed. And then we're done. So that just gives you an idea of how a simple substitution didn't work, but a little bit of algebraic manipulation before a simple substitution did, provided that the derivative of the substitution also appears in the problem, or some factor of it. Then we're away laughing and it makes the problem a lot nicer. See you in the next video.